Assalamu alaikum and good morning. Today we are going to look at another type of connections for the DC motor, which is what we call the series DC motor. As you can see here, in series DC motor, the field winding is connected in series with the armature. We have seen this before in the compound DC motor, where we have another winding which is connected in parallel or shunt to the armature, in which the field excitation is coming both from the series and the shunt. However, in series there is no shunt connection for the field. The only excitation is coming only from the series windings. So the equations for the armature equations, including the field circuit, is given by this equation. So if you take KVL around this loop here, you can see that there is no field current here, because the armature current is equals to the field current. And there are three total resistance: RA, which is the armature resistance; RAE, which is the variable resistance, which is purposely added to control the field current to the circuit; and we have the resistance for the series winding, which is RSR. The back EMF is given by these equations, and since the flux per pole is proportional to the armature current, then we can remove the constant Ka and write it as KSRIA, which means that the back EMF is just equals to KSRIA omega m, and therefore the torque is going to be proportional to the square of the armature current. So if we substitute the expressions for the back EMF and the current in terms of the torque, we end up with the speed equations, which is the steady state speed equations of this series DC motor, given by this equation here. As we can see that the speed is inversely proportional to the square root of the torque. So a typical characteristics of the series DC motor is shown here. Since speed is inversely proportional to the square root of the torque, therefore at low speed then we have a very high torque, and at low torque we have a very high speed. And as we vary RAE, which is the external resistance that we added to the armature, then the characteristics will change, shown by the graph here. Therefore, by changing the characteristics through RAE, then the steady state speed can be changed accordingly.